So welcome to the video lecture series on theory of computation. In today's video lecture, we will be learning about the way of converting DFA to regular expression using Arden method. So this is one of the prominent method which we can convert a DFA to regular expression. So see, we have to follow a series of procedures in order to apply this Arden method. The first procedure is imagine that you have a DFA. Your DFA is composed of set of states. So you are supposed to frame an equation for all the states here. So all the states, you have to take only the incoming transitions for all the states, and you are supposed to form an equation. And suppose if the state is an initial state, then you have to add epsilon to equation. Okay. So that is step number one. So every state has to be considered as far as the DFA diagram is concerned. Now the second is you are supposed to convert a regular expression for final state, and if DFA have a final state, it will be having a final state, and you have to compute the regular expression for the final state. And if the equation is of the form R equal to Q plus RP, and then you are supposed to reduce that to R equal to QP star. Okay. So this formula we will be frequently applying in Arden method to just get the regular expression. And finally, if you have more than one final state, for instance, in this case, if you have QF and DF, so QF and DF are two final states, and the respective regular expressions are R1 and R2, then you have to just make a union of this regular expression. So final regular expression will be computed as R1 plus R2. So we will step into the problem. So we will just step into the problem and tell how to solve the problem here. So now in this case, you can see here I am supposed to convert this DFA diagram to regular expression. So we have an initial state called as Q1, and we have a final state called as Q3. Now we will first step we have to form the equations. So first step, form the equation. So see here, the equation is just, we will start with Q1, and you have to consider only the incoming edge. So in Q1 we have only one incoming edge, that is, it is starting from Q1 and it actually ends in Q1. So it starts in Q1, and the input is actually 0 here. So Q1 0. Since this Q1 is going to be the initial state, just add epsilon. Okay, and this state equation is named as equation number 1. Now we will come to the second state, Q2. So Q2, you have one incoming transition, two incoming transitions. One is from Q1 and another is from Q2 itself. So now we will take Q1 1, and Q2 is actually Q2 1, and this is equation number 2. Now we will go for Q3, that is going to be the final state here. So Q3 is equal to, so Q3 have 3 transitions. So one is from Q2 and 2 transitions from Q3 itself. So Q2 0 plus Q3 0 plus Q3 1, and name this state equation as equation number 3. Now I said that you have to compute the regular expression for the final state here. What is the final state? The final state is actually Q3 is called as final state here. So you are supposed to convert the regular expression for this Q3. Now the problem here is when you take up Q3, you should know the value of Q2. Okay. So if you unless and until you know the value of Q2, you cannot find the regular expression for Q3. Now if you go to Q2, you should know the value of Q1. Okay. So Q1 is there, so you should find the value of Q1. So once you find the value of Q1, then only you can find the value of Q2. Once Q2 is found, then only you can find the value of Q3. Okay. So this problem has been framed like that. So first we have to identify what is the value for Q1. Now I just take up this equation Q1 0 plus epsilon. So I will rewrite this equation in this form. Q1 is equal to, I use epsilon Q1 of 0. Okay. Now you just apply this equation to the standard format. The format is actually R equal to Q plus RP. Okay. So if you take this format and just apply in this equation, you can see that R is actually Q1. So left and right you have Q1 here. So R is Q1. So this portion is called as R, and this is called as Q, and this is again it is called as R, and this portion is called as P here. Okay. So now you can just, if that is the case, then you can just take up this R is equal to, you can rewrite it as QP star. Okay. So now what is R here? You can rewrite this equation. So rewrite the equation Q1 equal to Q is epsilon, and P is actually 0, and you can put star here, 0 star. Okay. So so you can just reduce it. So to reduce it, you should know the regular expression equation or formula here. When epsilon is multiplied by regular expression or R multiplied by regular expression, the equation is R. You will get always R. Okay, if anything is multiplied with epsilon. So here epsilon is multiplied with 0 star. So you will get Q1 value. So you will get Q1 is equal to 0 star. Okay. So now I got this answer Q1 equal to 0 star. So name this equation as equation number 4. Okay. So this is equation number 4. Now, now I know the value of Q1. Now I have to apply this value in Q2. Okay. So I just simply write, so Q2 is equation number 2. So apply the value of equation number 4 in equation number 2. So apply equation 4 in equation number 2. Okay. So I just see here Q2 is, you get Q2 is equal to Q1. So Q1 I am going to substitute with 0 star. Okay. So Q1 is substituted with 0 star, and you have already 1 over there plus, and you have Q2. Okay. So this is the resultant output when you try to apply 4 on equation number 2. So if you apply it, so see here, you can just apply this equation to the standard format, R equal to Q plus RP. Now this is called as R here, and this is Q, and this is again R, and this is P. Okay. So you can reduce it. Finally you will get, when you reduce it, R equal to QP star. So what is R here? So you will get Q2 equal to, and Q is 0 star 1, and P is 1 here. So 1 is actually, you can just put star for this P. Okay. Now you have got the value of Q2 now. So this is named as equation number 5. Okay. So now finally I want to find the answer for Q3. That's it, isn't it? Okay. So Q3, I need the value of Q2, but Q2 value has been already obtained. Now we will just go through equation number 5 and apply in equation number 3. So I will take, so apply equation number 5 in equation number 3. Okay. If I apply, what happens? Now the value is Q3. So Q3 is equal to Q2, you know what is the value. So Q2 is actually 0 star 1 star. So and already 0 is there plus. Okay. So Q3 you have 0 and 1. Okay. Now see here, Q3 is equal to 0 and Q3 is 1. Okay. So now what I have to do here is, it's very simple. Now you can just reduce this Q3. Q3 is a common term for 0 and 1. So I can just reduce this Q3. So Q3 is equal to 0 star 1 1 star 0 plus Q3. I take out Q3 as common term, and what is remaining? 0 and plus 1. Okay. Now you can apply this to the standard format. What is the standard format? So this is called as R, and this is called as Q. This is again R, and this is P. Okay. So you can just reduce it now. So when you reduce it, so you will get the answer called as R is actually Q3 here, and Q is 0 star 1 1 star 0, and P you can just get 0 plus 1 star. Okay. So this is the regular expression for the given problem. Okay. So that's it about Arden method. So thanks for watching the video. Have a good day.